עכשיו נעבור לויטלי שתספר לנו על... טוב, לא אספר לנו.
ספר.
אני לא רוצה להרוס.
אחד. Yo. So it's very nice to be here today. We're going to talk about React performance, and as Daniel said about Node.js performance, to make your performance good, you got to understand how the things that you're using are actually working under the hood, or at least understand how they're working, and then it will be much easier to make your things work fast and nice. So who's working with React? Okay, that's cool. Who understands how the virtual DOM works? Yeah. We don't really understand how it works. Actually, when I started to make this lecture about the virtual DOM, I thought that I understand, but in the process of making it, only then I think I understood it somehow. So my name is Vitaly Zaidman. I work from welldone software. I'm the front-end expert of welldone software, although actually I'm a full-stack developer. welldone software is a very cool company. We work with other companies. We help them to solve hard problems, help them migrate from technologies to other technologies, working from home. So it's a very cool place. I work in React since it was published, I think, for quite some years now. And my last project was this one. I think it looks a little like Wix. Who works in Wix here? Yeah, so it looks a little like Wix, but it's actually a presentation that you can export. For example, that's a presentation we made that we exported to YouTube. There's a lot of features here. Like you can add slides and you can do, I don't know, resizing things, moving things around. There's a timeline. So it's a very, very huge project. And as you can see, it works quite nicely. And everything you see here is actually a lot of divs, and it's just React Redux. Okay, so that's where my knowledge is when I was working on Python. Okay, let's start. So first of all, let's talk about what Donald Knuth says. He says that we should forget about small efficiencies, say 97% of the time. Premature optimizations is the root of all evil. Yet we should not pass up our opportunities in that critical 3%. That's a very, very important thing. And it's not only important in performance. Actually, you know, when you start developing something and you move to styling it too earlier, and then the requirements change a little, and then you refactor something, and then you style it again. So it has to do with many things. Donald Knuth is a very important scientist, mathematician, and computer scientist, and he knows what he talks about. So yeah, it's definitely true. And especially about React. React is very, very fast. Usually we don't need to optimize anything. Just write the most clear code that you can and it will be cool. But we got to learn to recognize this 3%, and that's what hopefully I will achieve in this lecture. Okay, so performance matters. It's a very, very important topic because a lot of times the production guys, the product department, ask us to create a lot of features, and they really, really focus on it. But actually performance is money, okay? We can look at Pinterest that increased their site search engine traffic when they reduce their perceived wait times. not even real wait times, only the perceived wait times. Probably added some loader or something. And all this information is from a great study by Google. I really urge you to read it. It's very cool. Because the moment your product department will know about that, they will give you the time and the resources to work on performance. That's very, very nice. Another important thing is to focus on what matters, because if you have, let's say, like 2 hours to work on performance, you got to do the right thing in these 2 hours. So one thing is to understand that your users are using very, very different machines and browsers and very different things. For example, in Powtoon we have tens of millions of users and a lot of people from China, so they use Internet Explorer, and you got to understand what's your audience, and you got to know what's your real world scenarios, okay? Another thing is that your machine, especially my machine by the way, they're very, very strong. They're not like the machines that your users are using. Also, a lot of users are using old cell phones, so keep in mind that your users are using different machines, and it's very, very nice to know what they're using. There's a lot of tools for that. So, in general, it's an important thing. And also, it's important to set clear goals, because first of all, for example, it's really nice to have a machine in your office that is very, very weak, where you test your performance. Another thing is to test key features and to assign scores, for example, using online speed tests, but you can assign your scores to all kinds of things to actually know that you improved. Because sometimes you work on something and you think it improves it, but actually it breaks something else. So it's very, very important to set clear goals. I will focus on React performance in this lecture, but actually I think most of the issues are in the land of network or land of using the DOM without React, using too much things on your around the application, around the React. I think network is like the most important thing, but you can get really, really nasty things in React, and that's what we're going to look on. Okay, so that's the demo we're going to use. Let's run it. Good. The demo is very, very simple. The demo is simply a button, okay, a counter, and the father component, and inside it a child component, okay? The first thing is to notice is that, okay, I also added some consoles, so we can see when things re-render. So the first thing I want you to notice is that when I click on increase, the father and the child components re-render, okay? It's a little weird, right? Because actually the state that changed is here, but these two still re-render, although nothing changed there, and we will look at it later. But let's talk about React for a moment. Let's recap how it works at all. So we have our React components, right? React component is like a recipe of how to create some part of the DOM. For example, this React component creates a hi element, just says hi. Also we have React elements, which are created from the React components by using React create element, or by using this JSX notion, right? So we have React components, React elements, and also we have React component instances. React component instances are like the keepers of the life cycle of drawing some part of the virtual DOM. What is the virtual DOM? The virtual DOM is is something that simulates the DOM in React. It compares itself to its previous state all the time and decides how to update the real DOM. Okay? Any questions about this? Everybody understand everything? That's cool. So again, the virtual DOM, it keeps the state of the DOM and it updates the DOM in a very, very efficient way using these React component instances. They just keep track of what's rendered and what has to be rendered and what to do when it's rendered and all that. And now we have some examples to help us understand how it's work. So, first of all, if I take the child component and I move it to here, to be created before the demo. So this static child, would it now re-render when I click on increase? Anybody wants to guess? No. What? Yeah, it will not re-render. That's true. I'll show you. So what happens is, the moment we create child component, now the moment we static child is actually a React element. The moment we take child component and create a React element out of it, it becomes an immutable React element. Okay? So when the virtual DOM gets it, it just draws it. It's not, there's no state involved here. So it will not trigger anything. Okay, any questions about it? Cool. So, just prove it to you. Yeah, I'm clicking on increase. That's, I move to the branch where the static child is created there. And as you can see, indeed, only the father component re-renders. Okay, now, yeah, let's keep it. So, okay, now in this example, on every odd render, the child component will not have a father, right? So once it renders just the child component, then it renders the child component inside the father component. Let's look at it. You see, on every odd render, the child component has no father component. So, notice this. Can you see it? Yeah, so the father component and the child components are actually unmounted from the DOM. So this can be a very serious performance issue, because sometimes people put Ajax requests, for example, or do all kind of stuff when components mounted for the first time. And here, it always considers the component, it always calls component did mount, right? So my next question, which is kind of hard, is how to achieve a child with a dynamic father like this that will not unmount. Any ideas? Yeah, so this example proved me that I don't really understand React. And the reason is that React uses a convention, the reconciliation process. Okay, another important thing is to read React's README. Sorry, their docs are amazing. If you just read it just from the start to the end, you will be much smarter and you will understand all the things, no problem. So what happens in the reconciliation process is that the virtual DOM runs on your element, on the virtual DOM, runs on the hierarchy one by one. So here, for example, it runs on this component, then it gets to the button component, and then it says, okay, I had a father component, and now I have a child component. So it unmounts the father and mounts the child. It doesn't understand that the child is actually the child of the father because it uses a heuristic. What's a heuristic? It's a simple algorithm to achieve something, because if you really want to know what exactly changed, you could have done it in n to the third, but here it does it on just on. Okay, so who think we can't make the father component pure?
We're trying to prevent re-render of child component?
We try to prevent the render of all this part. Now, like now, if I click on increase, my father component still re-renders, right? So why won't we do the father component pure?
You don't need the child component to re-render, it won't re-render, no?
But if the father wants to render, the child wants to render too, right?
Yes, yeah.
No.
Okay.
Yeah, so this is a very, very common misuse of React components. Sorry, of pure components, because the moment we pass a child component to a father component, even if it's pure, it will still re-render. Why? Because the child component will be a new React element on every time it gets here, right? So here I use Bubble to show you how the JSX code actually looks in ES5. And as we can see, it first creates the child component, and then the father component gets it as its children, and it's just a pure misuse, because the father is pure and it compares its properties to its previous properties all the time, but still it will always re-render, okay? And I will show you how it looks if I put a debugger there. No, okay, first of all I'll show you that it actually re-renders, right? As you can see, the grid changes when the father is pure. And now, if I take the father component, I take the should component update function, and I add the debugger to it the moment it detects a different property, okay? It looks like this. Okay, so now it's stopped in the debugger. Why? Because its children is actually a React element. It looks like this. A React element, by the way, looks like this. It's all the React magic. Sorry, it's all the React magic you can imagine yourself. A lot of weird numbers that we don't understand, but that's a React element. The moment the child is recreated, we get a new React element, and that's why the father will always re-render. That's why our father can't be pure. Okay, now, a question. And what will happen if I make them both pure? Okay, I made them both pure. Do you think the father and the child will still re-render? Anybody wants to guess?
I guess the child will re-render.
The child will re-render? What do you say?
Because it still creates element, I don't know, it's a guess.
Yeah. So, and that's a very cool thing, I think. Oops. Oh, right, because I didn't. Yeah. Okay. So So yeah, so what happens here is that the child is not re-rendered, but we receive a new React element. Because again, every call to React create element, right? I'm talking about this code, right? The moment you do something like this, you receive a new React element, even if it's pure. You can, in fact, the fact that it's new doesn't mean that it will not re-render again, but every call to this will create a new React element, and it will trigger the father's re-render, but the child is still pure, okay? So the child will not re-render itself. And yeah, so we can see here that the child doesn't re-render itself, but the father does. So what we learn from it is that if a component has children, don't make it pure, okay? It's a very important thing. The moment you make it pure, you lose from all sides. From one hand, you do all these comparisons in should component update. From the other hand, it's always true, because it always has a new child React element, okay? Wait, another thing. What if I create my child component here? Anybody wants to guess? What will re-render? Would the child re-render first of all?
No.
No, the child won't re-render, and the father?
No, if it's pure.
The father is pure, yeah. No? Yes, you're right. The father won't re-render. As far as I remember, oh no, let's see. So yeah, so I click on increase and nothing happens, because the father's children, which is this, is always the same in this case, right? So the child compares itself, and it says I want to re-render, and then the father compares its properties and says I want to re-render too. Okay. Now this beautiful library, why did you render? I'll show it to you. It's a library that I wrote. Really glad. It's a very cool library because it catches things like this. Oops. Doesn't catch it for some reason. Okay, because everything is pure here. Got to revert it. Yeah, so what we see here is the, oops, is that why did you render screams at us that the father component re-rendered because its children property changed. Different React elements with the same display name. If we go to the link, we get a very nice explanation how to fix it. But the cool thing is that I actually want to show you how it works, because we got a little into React. So what I do here is that I take React create element and then monkey patch it. Does anybody know what's monkey patch? It's a very cute thing. It's something that you usually don't do, but here I do it. I take the create element, I put it aside here, right? I put the original create element aside. Then I'm doing something with the function, we'll see it in a moment. And then I'm using it for React. So whenever we get to creation of elements like this, it doesn't use the actual father component, it uses my father component. It uses something that the library creates. It looks like this, okay? This component extends the class, and it puts a little code in render to track what renders, and then it tells you if what renders is not supposed to be rendered. Okay, so that's a very cool library. It's one of the best tools, I think, to catch things like this. But what does it mean to be pure? I really like this title. What does it mean to be pure? So, the moment we made our child pure, we lost a small part of the application. We lost how it works. Because, and they moved to 10,000 items again, because when we click on increase, this doesn't change, right? So we actually changed the behavior of the application when we made the child pure. And these were, okay, first of all, question. Any guesses how can we achieve this behavior, like changes this grid when I click on increase?
Pure component?
No, I want to change it when I click on increase, but make it fast somehow. How can I make this part fast, right? When it's pure, it just doesn't render at all when I click on increase. Nothing happens here. But if I do want to make some beautiful grid here when I click on increase, any suggestions? What? Okay. So I do have one very cool example. Before I show you the beautiful example, it's really important to work with the product department about performance, because sometimes you have to adjust the product itself to achieve nice things. For example, I can add some loader here, or for example, maybe the product didn't even want this to change. Maybe they will tell you, okay, just keep it like this and it's nice, it works fast, right? But here, I do create something nice. I'm using an off-screen canvas. And first checkout. Yeah, so here I'm using, okay, so it's million of pixels, right? And also, I slow it by 6, not by 4, okay? You see how fast it works? And what's the moral of the story? React is not good for everything, okay? React is not good for things like this. Always consider using other tools. For example, in this case, I'm using an off-screen canvas. The code is not as nice, right? It's a lot of code, and it's like you take a canvas and you draw on it, and you do things that are a little more complex than simply drawing divs in different colors. But it achieves very nice performance. But even here, it's not the same, because I made it to draw one canvas every 300 milliseconds. Right, so if I click a lot of times, it will draw it once in a while, right? But still, the behavior is different. So speak with your product department, explain them what can you make and how fast and what's the options, and work with them to decide how to make the things work. Okay, I got to the last example. I have to show you, and I think it's very, very common. It's just a big component, right? Raise your hand if you ever saw components like this in production. Yeah, so big components are disastrous. First of all, you can't read it, right? If I see something like this, I don't want to work with a company that does it, right? And another thing is that when we get to render, it starts with putting something on the local storage, then it calculates something regarding passwords. Oh, I didn't even show you the program itself. So I'll show you the program. Yeah, it's a completely different program. It looks like, wait. slowed it too much. No, actually, let's keep it 6. Okay, so it just forms, right? Nothing too fancy, but there is something a little fancy there. Also, it validates that the telephone number fits your country, so it uses some parser library for the telephone. Also, it creates a function for this part. Oh, you can see how slow it works, right? When I click, make a click. Okay, so that example. Okay, actually, it's very, very slow. And also it has some list that it sorts for this, okay? And it all happens in render. So what we see here is that even if I click, even if I do something here, it still works on the derived data of this part. This is something that we don't want to happen. We want only the right derived data to be calculated when we need it. So what's the solution? I added some comments here. So first of all, this local storage set item that saves our current state, it would be nice to move it to component did update, to do it after the render instead of in the process of render. Also, we can debounce it to not do it too many times. This should move to its own component, which is working on the password, making sure the password is right, parsing it, doing all kind of things. The same about telephones, just breaking it into smaller parts. And that's how it looks out after the refactor. Okay? A lot of small, pure parts, where if I go and I change so here, if I change the name, if I click here, the only thing that renders is this small part, right? Because everything else is pure. Everything else doesn't receive new properties, okay? Any questions about it?
If I didn't make the child component pure, it would be the same, right?
The child component, you mean this component?
Yes, if they weren't pure.
Yeah, it doesn't matter, it shouldn't be pure. What's matter that all of these are pure, each of these. For example, the telephone field, it's a pure component. It's just an example of one of the fields here. And the beautiful thing here is that when I change the name, for example, none of its properties change, and that's why the telephone field doesn't calculate anything at all.
No, but it was my question. If I did the refactoring to break it to small components, but the child components were not pure.
It should not be pure. There's no reason for it to be pure.
Oh.
Yeah, because what matters for you is that you don't want them to render, right? But when you click somewhere, you want this component to render. Actually, you don't even care if this component re-renders too many times, like a lot of times, because all its parts are pure. So even if it re-renders, it doesn't cost you anything, okay? So, also, first of all, it looks much nicer, as you can see. And now we will look at some of the React tools, performance tools of the browser to catch the things. So I already showed you this part to slow down your CPU. Also, you can slow down your network. You see I have these slow presets here because we work with the cell phones, we work with 3G. So it's something that you should use, your QA should use, everybody should use it. It's a very, very cool thing. Another thing that we can use is React's highlight elements. I'll show you how it looks here. Highlight updates, okay. So when I click on it, we can see that actually the whole component receives a new state, but from this component, the only thing that renders is the first name. If I go to password, for example, yeah, only this changes. If I go to the telephone, only the telephone chargers. So that's another thing that we can use since React 16.5, I think, or something like this. Another thing is this performance profile thingy. So now that's the quick version, right? So that's after the refactor. So if I click here, right, and then I will click on A for 2 seconds, from 5 to 7. Okay. Now we can look at the performance of this action, and Chrome breaks it. Also, we have very nice screenshots and stuff, but React breaks it into. Close the console. Okay, so first of all, we have this, which is React telling us what it actually does. Okay, so update of big form, for example, committing changes. It's very useful, and we can see that it took something like, I don't know, it took something like 6 seconds, I guess. And now I will show you how the slow version works. If I do the same. Okay, so I move to the slow version now. I will record it for 2 seconds, right? Let's do it. Okay. I think it will take a while because it's much slower. I think that every small millisecond where the button was clicked, we have this huge render process where it saves things to the local storage, when it derives data, when it does a lot of things. And here you can see that it's very slow. Okay, now it finished, right? So the moral of the story is to break your components into smaller components that are responsible for some of the data, and they're not re-rendered when other parts of the data change. One moment. I also want to show you how the performance tab looks like. This example. It builds the whole profile thing. Okay, let's give it time to build. So some things that we can do is to make sure we re-render only absolutely what we must, like we did here, right? And like we did with the child component. Use virtual lists for lists, and that's something that I didn't show you, but a very nice thing to do is, if you have long lists, to only show what the user scrolls to. You can achieve it with many libraries that does it. It's called virtual lists. And it just makes sure you don't have too many DOM elements on the DOM, and don't have too many React elements. Make sure to move heavy processes to happen before or after or in a parallel thread using web workers. Okay, so you don't want things to happen when your render process happens, because this is just blocking the I/O. This is just what's between what the user does and what the user sees. So you don't want to put too many things there. Memo is derived data. It's you can use reselect or you can use other things, but don't calculate too many things. If you have a calculation already in hand, save it somewhere and use it afterwards. Break components into smaller pure parts, and use things that are not React. As we saw before, I use canvas, off-screen canvas. That's it, I guess. So React provides us with a tool, with a virtual DOM, and we have to use it wisely. We have to understand how it works. and make sure that your render processes are as small as we can. Also, it's like what you said before. So, like in Node.js, we want to keep the Node.js callbacks as small as we can, right? Because it's just blocking I/O. So the same with React. Keep your React functions as small as you can. That's it, I guess. So that's my information. You're free to send me stuff and also read my stuff on Medium. I'm going to write a lot of interesting things. Oh, actually I wrote a lot of interesting things and I'm going to write about tests and stuff. That's it, questions?
You almost didn't touch Redux, Movex, data management.
Yeah, I didn't touch it, because the moment you understand how the flow works, I think it answers your questions too. Just, if you use Redux or Mobix, you don't want renders to happen too much, because updates in the state, right? And also you don't want to derive data you don't want deriving data too many times. That's essentially the thing. Who feels like he understood something new? Learned something new? I'm very happy. No more questions? Cool, so thank you very much.
תודה רבה, תעקבו אחרינו בmeetup.com ונתראה.